Brilliant, thank you very much. So, good evening, everyone. Thanks for coming out to the Stripe office. So, as was mentioned, my name is Marcus Dalton, and I'm a Solutions Architect here covering the Irish and the UK markets. And I've spent the last 10 years in the payments sector in many different roles. Though fair warning, even though it's been mentioned a couple of times, there is some technical detail in this presentation. I'm not actually a die-hard developer myself. So if I say something that offends your engineering sensibilities tonight, please be gentle on me. So with that, what I want to talk to you about is strong customer authentication, specifically the gap between now, beg your pardon, how it was implemented in 2019 and how it should be implemented in 2026. Most teams treated Payment Services Directive 2 as a compliance exercise, both on the bolt-on 3D secure, tick the box, move on. But the side effect of that was friction. So step-up challenges, mobile drop-off, authorization declines. But what's changed now is that you have enough of tools to route around almost all of that friction, and the teams doing it well are seeing it show up directly in conversion. So we'll cover how the transaction routing decisions work, what's actually happening inside the browser when 3D Secure runs, how Stripe billing handles the recurring payments problem automatically. Nice nod to Stripe billing in the last presentation, by the way. And when you want to reach past that abstraction layer entirely, you can use 3D Secure to do so, and or standalone 3D Secure to do so, and I'll talk you through that. So let's get into it. Cool, from checkbox to conversion engine. Now, I am going to pause for 1 second because I was having a chat with Ben and Alison ahead of the talk, and they were talking about the type of audience that we have here today. And immediately I was like, oh no, have I made too many assumptions? So to start off with a tiny bit of a glossary, you may hear me use some acronyms and phrases, and I'll give a quick context on what some of those are. So Payment Services Directive 2, or PSD2 for short, was a European Union directive which came into force in 2019. And part of that was a mandate for strong customer authentication, which meant that online transactions had to authenticate the customer at the point of purchase. The most, I suppose, tangible version of that you might be familiar with is 3D Secure, specifically 3D Secure version 2. This is where you might be buying something online and you go to click pay and all of a sudden a box pops up saying verified by Visa or MasterCard flavor or Amex flavor, and you need to biometrically authenticate yourself through your banking app or wait for a one-time passcode, etc. So as you can probably relate to, that is obviously a protection there to protect your payment method from being used fraudulently, but evidently it introduces risk, or sorry, not risk, friction. So 2019, PSD2 comes into force across Europe, and the Financial Conduct Authority in the UK and the Central Bank of Ireland starts enforcing strong customer authentication shortly after. The response from most engineering and product teams was essentially panic. You know, the path of least resistance was to apply 3D Secure to everything, every transaction, every card, every customer. Safest interpretation of the regulation, and nobody gets fired for being overly cautious. However, the problem is that friction has a real cost. When you force up a step-up challenge, that one-time passcode flow that I mentioned to biometric, etc., the customer has to jump into their banking app or wait for a text. Roughly 1 in 5 of them just don't complete the transaction. They abandon the checkout, on mobile especially, and that's a brutal hit for users who sell online. Now, here's the thing that tends to get lost in the compliance framing. The EMVCo protocol that underpins 3D Secure 2 hasn't changed. The same authentication flow that was causing that drop-off in 2019 is still running today. But what has changed is the strategy around it. Because by now, if you're doing this well, somewhere between 70 and 80% of your in-scope transactions are authenticating completely silently. No one-time passcode, no redirect, no friction. The customer never even knows that it happened. The issuer's risk engine is looking at device signals, browser fingerprint, transaction history, and making a call, I'm satisfied, there's no challenge needed. The teams hitting those numbers aren't necessarily doing anything exotic or anything overly creative. They're just routing transactions correctly, applying exemptions where they exist, and letting the protocol do what it was designed to do. So where does your transaction land? Before we get into the mechanics of 3D Secure, it's worth spending a moment on categorization, because the first question shouldn't be how do I do 3D Secure, it's do I even need to do 3D Secure? Every payment you process falls into one of these three buckets. The first is out of scope, transactions that Strong Customer Authentication simply doesn't apply to. The one of these which you might be most familiar with is the likes of merchant-initiated transactions, where the transactions are happening off session, so you can't actually authenticate the customer at that point in time. You've already obtained the Strong Customer Authentication consent when your customer initially signed up on a previous session. Subsequent charges on that mandate don't actually require it. The second bucket is exempt, and this is where most of your e-commerce everyday transactions will optimize properly. The low value exemption, for instance, very similar to contactless when that was first introduced. Anything under 30 euros can go through without having to go through Strong Customer Authentication. Transaction risk analysis as well, or TRA for short, covers up to 250 euros if your acquirer's fraud rate is at or below 0.13%. Surprise, Stripe's fraud rate is below 0.13%, so Stripe applies TRA automatically on your behalf. If the transaction qualifies, it's handled without any configuration on your part. The third bucket then is in scope, so the box on the right, Strong Customer Authentication required. And even here, the goal isn't necessarily to put your customer through a challenge successfully. The goal is to authenticate them frictionlessly. The challenge flow is the fallback, not the design, not the target. The decision tree down the bottom, hopefully you can see it, I realize it might actually be a bit small text now, but nonetheless, is the routing logic running on every transaction. And on the next slide, we'll have a look at exactly what happens inside that authentication flow. Cool, so demystifying the black box. How do we authenticate customers on session without having to present a challenge to them? So what's actually happening when a transaction goes through 3D Secure Authentication? This is the part that I actually find genuinely fascinating, and once you see it, you'll understand why getting through it is it's non-trivial. Step one, when your checkout page loads, Stripe.js is quietly collecting browser and device signals in the background: screen resolution, color depth, time zone, user agent. This happens before the customer has even clicked pay or gathering this data about them. Step two, and this is one that surprises a lot of people, Stripe actually injects a hidden iframe onto your page pointing to the issuer's ACS. That's their access control server at the cardholder's bank. The ACS itself then fingerprints the device directly through that iframe. No Stripe intermediary, the bank is actually profiling the device and the browser itself, which is the data its own risk engines trust the most. Step three, all of the data that Stripe has collected gets packaged into an authentication request, and the authentication request itself actually contains around 150 data points that we're collecting about the customer, the merchant, the transaction profile, the device, the browser, etc. And we dispatch all of that to the issuer. So you can imagine, at this point in the transaction flow, the issuer has captured the device data themselves. They've also received all of those 150 data points from Stripe. They're in a pretty good position then to make the decision as to, is this actually Marcus, or do we have to step up to a challenge? So step four, the issuer's risk engine returns an authentication response at that point in time. An authentication response of Y means silent, frictionless authentication. So you get your ECI code, your authentication value, and the liability, and this is the key value add of 3D Secure ultimately, the liability for fraudulent chargebacks shifts from the merchant to the issuer. But nobody saw anything on the front end. There was no challenge to the customer. They didn't have to do a one-time passcode or anything. If an authentication response code of C comes back, this means the ACS wants more confidence. At that point in time, the checkout renders the challenge window and the customer completes the one-time passcode authentication or biometric. Same outcome, just different approaches. The good news is the Stripe checkout handles every single one of these steps, so you don't have to. The iframe injection, the authentication request assembly, the challenge user interface. I just wanted you to see what's going on underneath before we look at the abstraction layer itself. But before we do that, just one point on recurring transactions. I mentioned earlier that merchant-initiated transactions are out of scope for strong customer authentication, but the truth is there are mechanisms under the hood that demonstrates to the issuer that it is actually out of scope. So let's talk about recurring payments, because this is where a lot of teams actually get themselves into trouble. The initial transaction might have gone through successfully, but then all of a sudden your recurring subscription payments start failing. What's going on? So the legal framework says that for merchant-initiated transactions, subscriptions, installments, anything where you're charging the customer off session, you need a prior strong customer authentication consent. So I mentioned previously that you will do it while they're on session, but then you need to track that consent thereafter. The initial checkout must go through full 3D Secure, and the scheme transaction ID from that authentication must be passed forward on every subsequent charge in a daisy chain type fashion. The actual phrase for it is transaction grandfathering, which I think is kind of funny, but nonetheless. If you build this yourself, you're capturing the scheme transaction ID, storing it per payment method, and injecting that transaction ID on every renewal transaction, and handling the re-authentication yourself if an issuer ever invalidates it mid-subscription and decides it needs to re-authenticate. So it's the kind of thing that works perfectly in testing, but then quietly breaks at 3 a.m. 6 months post-launch. If, however, you use Stripe billing in combination with the Stripe checkout, you pass one parameter, which is mode equals subscription, and Stripe captures the ID thereafter for you and automatically applies it to the payment method and injects it on every single renewal transaction forever. Billing handles recovery too if the issuer ever demands a re-authentication. The trace at the bottom, although again, I think the text might be a little bit small, apologies, shows the 3 steps. The initial checkout session authenticates the customer and seeds the chain. The payment method stores the ID, and every subsequent invoice picks it up automatically and you never have to touch it again. Great news. So, the checkout abstraction layer. All of that to say, strong customer authentication, 3D Secure itself is pretty complex. But this is the slide I feel that crystallizes the central argument of this talk. If you wanted to go via direct EMVCo 3D Secure integration, or instead use a Stripe payment surface such as the Stripe checkout. On the left is what the raw EMVCo 3DS integration actually looks like. You're manually managing the hidden iframes. You're constructing the authentication requests with all those 150 data points I mentioned. You're parsing every possible authentication response code. And for reference, that's Y, C, N, U, or an A, and branching your flow accordingly. And you're owning the merchant-initiated transaction daisy chain for every payment thereafter forever. This isn't hypothetical. Teams have built this. I started to talk off by saying I've been working in the payments sector for the last 10 years. I was around in 2019 when this was first introduced, and I saw other payment services providers who pushed all of this complexity onto the users, and it was disastrous with checkout abandonment and subscription failures and all the rest that goes along with it. So it's thousands of lines of code, and every time the EMVCo specs update, we've had 3DS 2, 2.1, 2.2, 2.3, you're absorbing that maintenance work as well. On the right, however, is Stripe checkout. The iframe is auto-injected, the authentication request is assembled by Stripe servers, the challenge user interface is hosted by Stripe, and the trace ID is captured automatically as well. The entire left column is what you're not writing. That's the thesis in one slide. The underlying protocol is genuinely complex. It doesn't have to be your problem. Great. One slight pivot, however. So far, we've been talking about minimizing friction, so routing away from 3D Secure where possible. But there's a flip side that's worth spending a few minutes on. I mentioned the fact that, 3D Secure doesn't exist in a vacuum. It does exist to serve a function and to provide value to the merchants who implement it. 3D Secure, when it's complete successfully, shifts liability for fraudulent chargebacks from the merchant to the issuing bank. That's a significant commercial protection. And it means there are scenarios where you actively want to force authentication, not necessarily to comply with a regulation, but to protect your economics. The Radar rules engine lets you do exactly that. So the DSL on the left gives you the fine-grained control. Force 3D Secure on, say, high-risk transaction scores, on country and IP, or card country and IP country mismatches, on new customers, on high-value transactions, on cards with unusual velocity in the last hour, etc., or a combination of all of these signals. I've seen this firsthand with certain online retailers who've decided to introduce strong customer authentication for new customers who come in with a high basket value. So you're new to my website, you're suddenly loading up a cart with a lot of expensive goods. I want to make sure I'm protected, so I'll force strong customer authentication on your initial purchase, but returning customers get the convenience of frictionless. Cool. The table on the right is the payoff. So if 3D Secure completes, frictionless or challenged, all transactions later disputed as fraudulent, the issuer bears that cost, not you. If you process without strong customer authentication and take a fraud charge back, it's yours. So to apply that to that same example a second ago, if I were to ship a basket of, for argument's sake, 249 euros, just below the TRA limit, and I decided not to apply 3D Secure and it benefited from the exemption, I've now lost the sale value, I've lost the value of the goods that I've shipped, and I'm probably going to get hit with a chargeback fee as well. So forcing that dynamically can have real benefit. So radar integration here isn't fraud prevention in the traditional sense. It's actually a deliberate decision to accept a small amount of additional friction on specific transaction profiles in exchange for a guaranteed liability position. For merchants with elevated chargeback exposure, that's a really meaningful profit and loss lever to pull. Great. Now, given the audience that's in the room, I think it would be remiss of me not to touch on the escape hatch, which I refer to as Standalone 3D Secure. So the last use case is for the architects in the room who are thinking, this is all great, but my situation is more complex than checkout can handle. So the good news is Stripe exposes the authentication layer directly through the Standalone 3DS API as well. So the authentication value is the e-commerce indicator that you can use independently of Stripe's payment processing. Generally unlocks 3 patterns that we tend to see where users want Standalone 3D Secure. The first is delayed authorization. So you might be familiar with this, but it's entirely possible to authenticate somebody while they're on session, but not actually charge them to a later date and point in time. So that authentication value that you generate during that 3D Secure actually has a validity timeline that extends, so you can actually charge the card the following day, a couple of weeks later, in many cases up to a full year later as well. So separating the authentication from the authorization may suit your use case if you need it. Second, 3DS requests are initiated, or 3RI for short, is a multi-merchant basket use case. So a single authentication at the platform level covers all downstream merchants. Each sub-merchant receives the same scheme transaction ID and processes that through their individual authorization. So to give probably the most common example of this, if you think about an online booking platform, if you want to go on holidays, you're on session, you fill your basket up with your airline, hotel, car hire, travel insurance, etc. You want to authenticate the customer for the full basket amount, but there may actually be multiple transactions taking place under the hood. So one authentication can then be reused across all of those transactions up to the total amount authenticated. So that's the 3RI use case. And third, and the third one tends to get most interest from some of our larger enterprise users who want multi-processor capabilities, using Stripe purely as a 3DS authentication engine while routing the actual settlement through a different acquirer. So in that regard, you get the benefit of Stripe's machine learning frictionless optimization while still keeping your incumbent or your secondary processor if you want to do the dual processing. The API returns the raw ECI value, which is the e-commerce indicator, the authentication value that demonstrates that the transaction was authenticated, and the 3D Secure usage indicator value as well, which needs to go through in a subsequent authorization. Plug them into whichever processor you're using downstream, and the transaction should be accepted. Great, and that's the talk. But there are 3 things I wanted you to take away. It might sound a little bit of whistle-stop tour, and I hope didn't get too much into the weeds in terms of the technical details, but 3 main points to take home with you. Stripe Checkout handles the entire 3D Secure 2 protocol stack behind one API call. If you're building e-commerce on Stripe, we highly recommend that you use Stripe Checkout. If you have a subscription business model, mode equals subscription in your checkout sessions API call is the complete recurring strong customer authentication solution. So again, do that rather than trying to build out your own recurring logic. Standalone 3D, and if your architecture genuinely needs raw control, I should say, delayed auth, multi-merchant flows, or different acquirer for settlement, then standalone 3D secure is your escape hatch. So, thank you very much for listening to me rant on about strong customer authentication. And yeah, I'll take some questions if there are any.